Last time we were talking about regression, and we are going to finalize today, right? Remember, we spoke about regression. It means relationship between variables, and we are going to see how to determine if those relationships are strong, weak, or maybe if there is or there is no relationship, right? So I'm going to try to share my screen and we are going to continue from there. A bit slow, I'm just trying to, okay. Just waiting for a few minutes. I think it's a bit slow what I want to do. Just I'm sharing my screen, but it seems to be a bit slow. Yes, we are there. So as you can see, in order for us to find the relationship between two variables, we're going to use what we call a correlation coefficient, CC. And the correlation coefficient, we're going to use small letter r. So wherever you are going to see small letter r, it means correlation coefficient, right? So this is what we're going to do. So for us to determine if there is a relationship, we are going to use correlation coefficient, small letter r. So what we need to do, this is just an example. We are trying to predict if the price affect the quantity purchased by our customers. So we are going to see if the price of something will affect the quantity purchased, right? So we are trying to find the link between a price here and quantity. So we are trying to see if the price will affect the quantity, right? And this is the table here. So in order for us to do so, we need what we call correlation coefficient. So the correlation coefficient will show us if there is a relationship or there is no relationship, right? So what we're going to do now, those are the two columns. There is price, this is the X column, and there is the quantity, this is the Y column. So what we're going to do now, in order for us to find the relationship or the correlation coefficient, what we're going to do, we need to find the sum here. So we're going to find the sum of all the prices, sum of all the quantities, and here we're going to find sum of the prices times quantities, and we're going to find the x squared, y squared also, right? So just waiting for I'm using different software that makes my my computer being slow. Oh, just waiting for a few minutes. I'm sure it's gonna be fine. So we are here. Let me find my calculator first. So what we're gonna do here, so it's gonna be the sum of x. 5 is gonna be 12. There it's sum of y. That's gonna be 25, like 79. From here, it's x times y. So 15 times 2, that is 30. The 20 times 3, that is 60. 5 times 24 will be 20. That's going to be 120. And here, 20 times 2, that's going to be 40. And here, it's sum of x times y. That's going to be 220. That's going to be 250. And here, it's x squared. It's 2 squared. Squared, that's going to be 4. 3 squared, that's going to be 9. 5 squared, that's going to be 25. 2 squared, that's going to be 4. And sum of x squared, that's going to be 11, 36, 40. And here it's y squared. 15 squared. That's going to be 2, 2, 5. The 20 squared. That's going to be 400. The 24 squared. That's going to be 576. And here 400 again. And sum here of y squared is plus 400, plus 400 again, plus 225. So the sum here is 1611, right? So this is what you need to do. Those are your two variables. You need x times y, the x squared, and y squared, right? Like in order for you to get the correlation coefficient, right? Let me stop sharing first. So we are trying to find the relationship between two variables. The relationship between price and the quantity. We are going to understand, we are trying to understand, so if the price of a product can affect the quantity that we are going to be selling, right? So in order to do so, we need to calculate, we need to compute what we call the correlation coefficient, right? Correlation coefficient will be represented by small letter r. Now, in order for us to get it, it's a long formula, but that formula for the coefficient is very easy, right? So in order for you to find the correlation coefficient, it's very easy, right? But you need the column of x, first product, the column of the second product. You need the product of two of them, like x times y, first product, or first, like price times quantity. You need like x squared column, and you need y squared column, right? When you know them, you just go to the formula and you replace. Very easy, right? So I'm gonna share again and go back to my, yeah. Now, because we are done here, right? Now, this is basically the formula that we are going to be using. The formula for the correlation coefficient. Very easy formula. So what we're gonna do here, we're gonna just replace, right? Let me see if it's gonna be very easy for, yeah. So we are going just to do the replacement. So what we're going to do here now is R. Remember, this one is N. Your N here is 4 because you got 4 variables. So it's going to be, so here it's going to be 4 times like sum of x, y. This is your value here. So this one is the one that will come here. Times 250, right? Minus sum of x, remember, is this one that will come here. It's 12 times sum of y, this one, times 79, right? Divide by, you see how easy it's, right? Divide by, now this one is the square root. I'm going to do it like this. Your n is 4 times sum of x squared. This is the one, this one here. This is the one that's going to come here. That's going to be 40 minus sum of x squared. It's this 12 here, this one. This is the one you're going to put here, right? Sum of x. So sum of x is everything squared. Means that it's 12 squared. So that's going to be like 12 squared and times you open another square root here. It's n, it's 4. Sum of y squared. It's here 160 times 1601 minus sum of y, everything squared, is your y is 79 squared. And here it's going to be 1000 minus the 12 times 7. That's going to be the 84. Divide by what? Square root here. Like 40 times 4. That's going to be 160 here. Minus the 12 times 12, 144. 144. Like times again. 4 times 1601. 6404 minus 79 times 79. That's going to be 6241. And you're going to come down here. So it's going to be 1000 minus like 84. That's going to be, so our R is going to be 16 divided by 160 minus 16 here. The times 6404 minus 6241. That's going to be 163. That will give us 916. Square root of 16 here is 4. And square root of 163, that's going to be like 12.77. Do your R is 4 times 12.77, that's going to be 50.916 divided by 51.8. That's going to be 916 divided by 51.08. That's going to be, so it's almost like 18, right? So looking at this 18, you find out that 18, your R is positive. So R is over, it's almost like over 0, right? So your R is positive. So when it's positive, means that there is a strong relationship, right? And we can conclude here, I don't know where, right? Yeah, but I didn't write it down. So you can see that your R is over 18 and your R is positive. Positive means there is a positive relationship, right? But there are also 3 cases. When you get like positive 1, we're talking about a perfect positive. And when you get 0, means there is no relationship. And when your R is negative 1, it's a perfect negative, right? Let me stop sharing first. So this is how to find your correlation coefficient. Very easy. You got your 2 variables. Remember, you need the column of x times y, the column of first variable times second variable. You need the x squared, y squared, right? Very, very important, right? When you know those 3, like x times y, x squared, y squared, very easy. Just go to the formula and replace, right? And when you are done, you need to look at your R. Your R, is it positive number, negative number, or is it 0? Right? When it's positive number, we're talking about positive relationship, right? It means those 2 variables are moving together. So it means when the price goes up, the quantity also does what? It goes up, right? And when the R is down, so it shows that when the price goes down, the quantity goes like up. So they are moving in 2 different positions, right? This is like actually the meaning of what we are talking about, right? But remember, this one is just an exercise that I did pick up. And there are also 3 cases. Sometimes by computing your R, you're gonna get number 1. Number 1 means it's a perfect correlation, right? So it's like perfect. We're talking about like perfect, negative, or there is no relationship, right? So plus 1, it's a perfect positive, perfect negative, or minus 1, and there is 0, right? So this is how to compute your correlation coefficient, right? Let me share again my screen. So now we're gonna come here. Let me first do this. So this exercise, you can try to practice yourself. You are trying to predict. So if the weight of a product like affect your sales, right? So if the weight of the product will affect your sales, you can just fill those 3 columns, and you go to the formula, you replace, right? Okay, now there is another formula that you can go for, right? You can try to find the correlation coefficient by using the standard deviation, right? So sometimes you don't want to go to the first formula. You can use the standard deviation in order for you to find the correlation coefficient. What is the formula? It's covariance divided by standard deviation of x times standard deviation of y, right? So there's another way of computing the correlation coefficient, right? You can go for what we call the second method. The second method, you're going to use the standard deviation. So you got those 2 variables, you find the standard deviation for the first variable, and you find the standard deviation for the second variable. And now from the formula, what you're going to do, it's covariance divided by standard deviation of x times standard deviation of y. Basically, this is the meaning. So what we're going to do now here, so I'm going to show you how to do it. Right. We're going to go back. So this is basically the formula. It's covariance divided by standard deviation of x times standard deviation of y. This R here is the correlation coefficient. This is the covariance between x and y. This is the standard deviation of x and the standard deviation of y. So the covariance is what? The covariance also will allow us to measure how 2 variables change together, right? So sometimes when you try to understand how 2 variables move together, you can use the covariance, right? So the covariance, it tells us whether increases in one variable are associated with increases or decreases in another variable. So what we're going to do now here, this is the formula for the covariance by itself. This is the formula, very easy formula. Sum of x minus the average, the mean, times y minus the average of y, divided by n minus 1. Let's do an exercise here. There is a location, distance from CT1, and the average withdrawal. So we are trying to find the relationship between someone's distance and his way of withdrawing money. So we are trying to find the relationship between distance and withdrawal attitude, right? Or amount, right? So relationship between CT and this average. By using what? We're going to use the covariance method, not the first method. You can see here, we're going to need the X bar, we're going to need the Y bar, and we're going to need this. Let's add first those columns here. So you need to add more columns there. Right? So this column here, this one, that I can add like another one also here, and this one, let me try to make it big here. Maybe I can also like insert the third one. Yeah. So here what we're gonna do, for me it's gonna be x minus the x bar, right? So this is this one here. And here it's gonna be y minus y bar. It's gonna be this one here, right? And here it's gonna be the we're gonna do this one, x bar. So we are going to multiply them, and here it's y minus y bar. Very easy stuff, guys. Remember here, your n is 4, right? Very, very easy. So what you're gonna do here, those are the sums that's gonna do here. Like sum of x, this is our x, this is our y, right? Like sum of x is 25, 30, like 32, right? And the mean here is 32 divided by 4, that's gonna be 16, that's gonna be 8. And here it's gonna be like sum of y 1.7 plus 1000 divided by 4, that's gonna be 1.7 divided by 4, that's gonna be 195. That's not the correct. Let's go back. I think I have a problem here. Okay. $900 plus, oh, I used the wrong one. Plus 1000, that's gonna be 1.8 divided by 4, that's gonna be, so your average here, your mean, it's divided by 4, that's gonna be 450. Now here it's x minus x bar, 2 minus 8, that's gonna be negative 6, 5 minus 8, negative 3, like 10 minus, it's gonna be 2, 15 minus 8, that's gonna be 7. And here it's the sum again. That's gonna be negative 6, negative 3, plus 2, plus 7. That's gonna be here, we get 0 here, right? And here, it's gonna be what? Minus 450, that's gonna be 450 minus 450, that's gonna be 350, that's gonna be 150, and minus 450, that's gonna be 50. And here, the sum here, it's gonna be 8950, that's gonna be 900. And here is the multiplication. 0 times 450, 0 times like 350, 0 times 150, 0 times negative 50. Remember, it's gonna be here 0, right? So there is no way you can continue because the formula here is covariance of x and y divided by like standard deviation of x like times like standard deviation of y, but here we have already 0. 0 divided by standard deviation of x. So there is no way we can continue there because the covariance already is gonna be 0. right? So there is no way we can carry on. So this is how you need to compute the covariance, right? Very easy formula. You just go here. Where is it? Just look at the formula, right? Very easy. Right, so here we are. Yeah, just look at this number. Right, very easy to find. So now you're gonna have your own like exercises that you need to practice, right? So from here, 0, okay, let's say this is a number, right? Let like standard deviation like of x be a number, a number. So it's gonna be 0 divided by a number, that's gonna be 0. And when these are gonna be 0 means no relationship, right? There is no relationship, right? But I don't want just to continue because you know how to find the standard deviation of x, you know how to find the standard deviation of y, right? Very, very easy. So basically, this is how to find the covariance, right? The covariance is like very easy formula. You need the column of x minus x bar or x minus the mean, and you need another column for y minus the mean, and you need the third column where you're gonna do x minus x bar times y minus y bar, right? So the sum of x minus x bar times y minus y bar divided by n minus 1, right? Yeah. And where we here, I was trying to find what, yeah, because there it's gonna be 0. So if it's 0 means like here, 0 divided by n minus 1, that's gonna be 0 divided by 4 minus 1, that's gonna be 0 divided by 3 minus 1, that's gonna be 0. So your covariance is what? 0. And when your covariance is 0, means that 0 divided by standard deviation of x times the standard deviation of y. And if this one is not 0, it means 0 divided by non-zero, that's going to be 0. So it means that your R is 0, means no relationship, right? There's no relationship, means the distance doesn't affect the amount withdrawn, right? So it means those two are not linked. Those two, there is no relationship between the distance, the kilometer, and the amount withdrawn, right? Let me try to give you another exercise just in order to be sure that you guys, oh, I was not sharing. Oh, this is bad. Yeah. So I was talking about this part here. Yeah. So I was saying if this part is 0, 0 divided by n minus 1 is 0 divided by 4 minus 1. That's going to be 0 over standard deviation of x times standard deviation of y. That's going to be 0 divided by a non-zero. That's going to be R0, means there is no relationship. Okay, let me just give you another like typical example. Maybe from there also you are going to master. Yeah. Then, okay, and I want just a short one. That's gonna, okay, there maybe it's gonna be your x. Let's say your x, your y. There we're gonna find your x minus mean, and there's gonna be y minus mean, and here we're gonna find like sum of this one times this one, right? Okay, let's say there is 2, there is 1, there is 3, and here it's 4, 2, 7, 7 here, all right? So like for this particular case, we are trying to find the relationship between x and y by using the covariance and the correlation coefficients. These are here. So what we're gonna do, we're gonna need the sum here. The sum of x, that's gonna be, it's gonna be 6 here. The sum of y is gonna be 13, and the mean here is 6 divided by 3. That's gonna be 2y3 because your n here is 3, and here your y is 13 divided by 3. That's gonna be 4.3. Now here it's 4, or it's 2 minus 2, that's gonna be 0. 1 minus 2, it's gonna be negative 1. Like 3 minus 2, it's gonna be 1. And the sum here, your sum here is it's 0. 0 plus negative 1 plus 1, that's gonna be 0. There it's 4 minus, that's gonna be 0.3. 2 minus 4.3, that's gonna be minus like 2.3, and the 7 minus, that's gonna be 2.7, and we can do the calculations here. So the sum here is gonna be 0.7. Okay, and 7 minus 4.3. Okay, now here it's the sum. It's gonna be 0 times 0.030, negative 1 times that that's gonna be like 2.3, and here it's gonna be 1 times 2.7, that's gonna be 2.7, and the sum here is gonna be 0 plus 2.3 plus 2.7, right? That's gonna be the sum here, like it's gonna be 5, right? Very easy. Now the covariance of those two variables is the sum of x minus the x bar times y minus y bar divided by n minus 1. This is your x minus x bar. It's what? It's this one, 0 times 0.7 divided by n, 4 minus, no, your n is 3. It's going to be like, so we already find this particular sum here. I made a mistake here. The sum of everything is here. It's already, we already got it here. So the sum here is 5 divided by what? Your n is 3 minus 1. That's going to be 5 divided by 2. That's going to be 2.5. So it means the covariance like of x and y is like 2.5, and your covariance is positive. So the covariance is positive. So, and when the covariance like is positive, means that these two are moving to the same direction. So x and y move to the same direction. Or like if the x increases, y also will increase. Right? And if like x decreases, y also will decrease. So if x is going up, y also will go up. And if x goes down, y also will go down. Basically, this is the meaning, right? With the table that I was talking about. Yeah, so basically, this is what you need to do and practice like over and over. Yeah, so this is how to find the covariance. And when you know your covariance, what you're going to do now, you know already those two are moving to the same direction, but you don't know if how strong or how weak those two variables are. right? In order for you now to know how strong or weak those two are, you need to find now the correlation coefficient. So the difference between the covariance and the correlation coefficient, the covariance will show only the direction. Covariance will show only the direction, will show the relationship. So if the relationship is positive or negative or zero. If there is a positive relationship, negative relationship or zero, right? So when you are done with the covariance, you know already like the direction of those two variables. Direction means how those two variables are moving. Are they moving together? This is positive. If one goes up, the second also will go up. If one goes down, the second will also go down. This is moving together. This is a positive direction. Negative direction is when one goes up, like another one goes down, right? And zero means there is no relationship. And remember, how to get the covariance, you need only two columns. And the last one, so you need like x minus the mean, y minus the mean, and the sum of those two columns, the answer that you're going to get divide by n sample size minus 1. Now, when you are done with the covariance, that shows you the direction, but you don't know how weak or strong the direction those two variables are. So the correlation coefficient will tell you the direction plus the strength, right? This is what I wanted to you again to understand. I want to share, but my mouse is not. Let me connect something here. Maybe it's gonna be fine. Yeah, I think my software also. So in conclusion, what we're gonna say is here. Let us go a bit up. Where is it? My conclusion. Okay. So the covariance like only shows the direction only, right? And oh, I'm not sure. I want to do something, but my pen giving me a headache. So I already disconnected. Okay, so the covariance gives the direction, and the correlation gives the direction plus the strength. Direction means like positive, negative, or zero, right? So those are the two things that you need to understand. When it comes to a direction, you can use the covariance. When it comes to direction plus the strength, you can use the correlation. What else? You know the formula already for standard deviation, and you know the formula for the standard deviation of y. So, and when it comes to r, it's just what? The covariance of x, like x, like and y, divided by standard deviation of x, 6 times like standard deviation of y, right? Very easy. So to summarize today's lesson, we spoke about how to know if two variables are connected and how to know the strength. For you to know how those two variables are connected or linked, you can use the covariance of x and y, the covariance of those two variables. What does it mean? The formula is very easy. Sum of x minus like mean times y minus mean divided by n minus 1. There's no need for you to memorize those formulas. When you will be writing your assessment, those formulas will be given to you. No need to memorize them, even at workplace. But you need only to understand that in order for me to get the relationship, to understand if there is a relationship, I can use the covariance. The covariance will show me the direction, and I have to know when I'm computing the covariance can be positive, negative, or zero. Positive means those two variables are moving together. When one goes up, the other one goes up, or when one goes down, the second also goes down. Or if the covariance gives me zero, means there is no relationship. And if the covariance is negative, means there is a negative relationship, means when the first variable goes up, the second one goes down. Or when the first goes down, the second goes up. They are moving in opposite directions. When you are done with the covariance, and remember, it can only show you the direction. Now, you need to understand how strong the relationship is by using the correlation coefficient, right? And the formula for the correlation coefficient is also easy. It's just the covariance divided by standard deviation of x times standard deviation of y. And remember, again, when your correlation coefficient r equals zero, means no relationship, or right? And when it's positive, shows that it's a positive relationship. So it's a strong relationship. And when it's negative, means it's a weak relationship, right? So thank you very much. I will be sending this document, and we are going to continue in our last part for this particular module. That's going to be samples. We're going to say how to determine our samples. That's going to be for next week, Friday. For any question, don't hesitate to contact me. Thank you very much.